Hello and welcome to Vermont's Next Generation Lake Assessment Interactive Report Tutorial Slam. This is a brief introduction to the Next Generation Lake Assessment Interactive Report. And if you find this not having as much information as you'd like, you can visit the 1 hour long version, which goes into much detail. But this is just to introduce folks to see if they want to dive deeper. So the first thing you're going to do is basically navigate to the website. So you basically could just Google Next Generation Lake Assessment Reports, and they'll bring you to the Watershed Management Division, Lakes and Ponds Monitoring and Lake Assessment page here. And what you can find here is that this will give you background about some of the sampling and how it's conducted. Basically, we go to the deep hole on the lake, which we call the index site, and we sample 10 physical habitat stations that are evenly spaced around the lake. And we also sample the tributaries. And if you scroll down, you can see the different lakes, you can see their towns and their lake acres. And I'm going to go ahead and click on Lake Willoughby so we can walk through that one. And when you click on a lake, the interactive report is going to pop up. And if you wanted to make it a little, I'm going to just try to make it a little closer so that we can see everything better. And if your lake disappears, you can just use this button over here and centers it back so that you have the lake back at the center of the map there. And what you see is the index site is shown here, which is the deep hole. And then you see the watershed outline and its score for how disturbed that watershed is. It's yellow because it's considered in fair condition. Anytime you see yellow, it means fair. When you see blue, it means good. And when you see red, it means it's in poor condition. And so, well, now that we're over here in this window, this is just sort of the overall sort of report card from the visit on the condition of the lake. It has these values here: total phosphorus, total nitrogen, chlorophyll A, alkalinity, dissolved oxygen were all taken at the index site. And the lakeshore disturbance, the lakeshore habitat, shallow water habitat, and physical complexity of habitat were all the products of the 10 sites around the lakeshore. If we go into the next tab, you'll see this water quality tab here. And across the top, you see the how those scores came out for total phosphorus, total nitrogen, chlorophyll A, alkalinity, dissolved oxygen. And you can see based on where this little dot is and what this concentration was that we found during our visit, and where that sort of falls in the range of good lakes in Vermont, poor lakes in Vermont, or fair lakes in Vermont. And you can see for every one of these water quality parameters, Willoughby falls well within the good range. If we look at the, now we see in the rest of these graphs, these are basically depth on the y-axis and the concentration for the parameters on the x-axis, and the top of the lake is at the top of the graph, and the bottom of the lake is at the bottom of the graph. And you can see this Lake Willoughby is rather a deep lake. So we're down at like 90 meters here with our instrument. And each one of these dots represents a reading that was taken along the way. In the first panel, we see a measure of water clarity called Secchi transparency. And during this visit, it was 6.1 meters. And this little dotted line here is the thermocline depth, which is the depth at which there is the biggest change in temperature. So temperature is shown here in blue, and you can see where that big change in temperature from the warm surface waters in the summer to the colder waters, that if anybody has dove in deep waters in Willoughby, even in the wintertime, in the summertime, there's very cold temperatures in that lake. We can see here on the green, these are all chlorophyll A readings, which is a measure of sort of algal density to some extent. It's very low because this is a ligotrophic clear water lake, but we do see it peaks at about 20 meters depth. If we look at the black, that's the dissolved oxygen, and we can see that at Lake Willoughby, even down at the bottom of the lake, there's still plenty of oxygen, which is something we would expect on a ligotrophic lake and is just remarkable in a lake this deep. If we look over here at total phosphorus, now we're getting into discrete samples, so samples that were taken. These samples were taken with an instrument, a hydrolab. These samples was taken with a Secchi disc. And now we're looking at, for some of the chemistry samples you're going to be seeing here, you see a different readings at different depths. So this little bar at the top represents the top 2 meters. So we have an integrated sample that we take from the top 2 meters, and we see that total phosphorus is very low at the surface of Lake Willoughby. It's 5.3 micrograms per liter. Then we have at the mid-epilimnion, which is sort of halfway between the thermocline and the surface, we have taken a sample with a camera where we can just go down to that depth and actually grab a sample. And then we have down here, which is it's the mid-hypothermocline, so halfway between the thermocline and the bottom, we have a reading that we take. And then we take a reading typically right a meter above the bottom, but our camera sampler didn't have a long enough line to get to the very bottom of Lake Willoughby. So this is actually not 1 meter above the bottom for Lake Willoughby. For every other lake in the state, we typically get to 1 meter above the bottom. And so these are the readings for total phosphorus. Similarly taken are the readings for total nitrogen. Conductivity, you can see, is being taken with that probe. It's pretty uniform all the way down. Sometimes you see it spike at the bottom if there's some release of different ions from the sediments. This is chloride, which is total chloride, and you see we have it from integrated sampler up at the top, 3.44 milligrams per liter, and we try to get it 1 meter above the bottom, which in Willoughby's case, again, was not 1 meter above the bottom, but we see that it's 3.19. 2 is the detection limit, so if we get a reading of 2, we do not think there's the lake is not showing evidence of road salt getting into it. However, if it's above 2, there's some evidence then that chloride is getting into the lake from road salt. If we move over here, we can see the pH profile, and as you go down, you can see how the values change. It's pretty neutral in Lake Willoughby. And then in this panel, we see calcium and magnesium. So you can see this is the magnesium reading, 1 milligram per liter, and this over here is the calcium reading, 15 milligrams per liter. Over here, we have iron, manganese, and aluminum, which you can see, again, these are from the integrated sampler at the very surface, which is the top 2 meters of the lake. And then we have dissolved organic carbon, which as of 2017, we were not routinely taking those readings yet, as our lab didn't have that capacity. If we're going back up to the top here, you'll see there's some, you can click to get to spring profiles for Lake Willoughby, which brings you out of the next generation lake report, interactive report, and brings you to this other website, which will pull up all the profiles that we have from spring for the lake. And you can see we have these going back to 1978 when we didn't take quite as many parameters as we do now. So that is another one of the hyperlinks here. If you want to see summer profiles, similar thing, you can click here. If you want to see the lake scorecard for Lake Willoughby, you can click on that other hyperlink at the top. This is just so that you can compare things. So let's say you wanted to look at how was the, this Secchi is 6.1 during this visit, but how does that compare to the Secchi readings taken in the summer over time? And you can see here that it's 6 is a little shallower than is typically measured in the lake, and you can kind of use this as a reference point. And then we'll go back to the interactive report, and we'll go to the habitat tab. So now the habitat tab summarizes sort of the condition of the nearshore environment, and there's really fun interactive tabs here. You can click on and off. You can see here along the state park or state forest will be state forest. You can see there are a lot of big trees. You can see there's the number of, sort of when the cover of small trees is greater, and you can go through and turn on and off these different characteristics. Over here on the right is sort of a summary of all those observations for the lake-wide assessment. And what we see are the metrics that were devised by the EPA's National Lake Assessment. These are using the Northern Appalachian ecoregion's thresholds for their cutoffs. And you can see that Willoughby scores fair for lakeshore disturbance. So that's how intensively we use the lakeshore. Lakeshore habitat, it does good. Shallow water habitat does good. And physical complexity, which is a combination of lakeshore and shallow water habitat, score as good. If we go to this next tab of habitat comparison, this uses looks at some other parameters, and it compares the condition of Willoughby, shown in green, to undeveloped sites and developed sites that are poorly developed in Vermont. And what we see here is that Willoughby tends to either be in even better condition than some of the undeveloped sites statewide, or it's certainly better than the developed sites. And finally, if you want to see the details that go into the Human Disturbance Index, you can find those numbers here. Next, we can move to the Inlets tab. If you click on that, then you bring up all the inlets that we were able to find on the lake, and you can see, you can toggle these parameters on and off to get a sense of which inlets might be contributing more of the different pollutants or just different concentrations. And you can see those displayed in the tables here as well. If we look, this table is for like physical measurements and observations. So percent, so like sediment delta, if you have a big delta, there may be some upstream erosion going on that's worth looking into upstream. And then finally, there's just some basic information about the outlet in this tab. If we go on to the protection classification tab, that gives us, so in the 1990s, Vermont did a lake protection classification system trying to get at some of the values that humans have associated with lakes that are not necessarily directly measures of water quality. So, for those who are looking for lakes that have a more wilderness-like feel or a wilderness-like feel, they may score in one of those categories. Willoughby obviously wouldn't score in either of those, but it has also unusual characteristics. So here it has a natural beach, it has natural ledges, bouldered shore, it's got steep slopes, it's got peaks, and it's got cliffs. So it's got 6 unique features statewide. And then finally, this tab is where you can pull any of the data you want out of this report and download it yourself. So that is the quick and dirty summary of the Next Gen Lake Assessment Interactive Reports. If you're interested in taking a deeper dive, I encourage you to look at the 1-hour recording which talks a little bit more about how to interpret some of the data that you're seeing here and goes into each one of the parameters in more detail. And with that, thanks so much for listening.